Alright, let's keep this fun going. Here's example number 2. Very, very similar as example number 1. However, there's a slight difference at the end, so this is a really important one to pay attention to. So I'm going to go ahead and read through this, and as I read through this, I'm going to highlight the important information. Again, we're looking for distance, rate, and time type things, and we know that we're going to represent it with y equals mx. So a truck leaves, so we know a truck leaves the garage at 1 p.m. and travels at an average rate of 8 miles per hour. Very slow truck, obviously. 10 hours later, so we know that time, right? We got our rate highlighted, we got some time highlighted. A second truck, so there's 2 trucks now, leaves the garage to catch up to the first one. So if it's catching up to the first one, obviously it has to be traveling faster. How fast? If truck 2 travels at an average rate of 40 miles an hour, okay, 40 miles an hour is a whole lot different than 8 miles an hour. What is this guy doing when he's driving? Is he driving a truck with 3 wheels? Are 2 of the wheels flat? What does this guy have? Like a Ford Raptor? Is this guy sporting an F-150? And this guy's back using the Datsun? And if you don't know what a Datsun is, type it into Google and see what that type of truck looks like. Anyways, if truck 2 travels at an average rate of 40 miles an hour, then how long will it take before it catches truck 1, right? So how long is it going to take truck 2? So we've identified the very important information, so we can go ahead and now try to put it all together. And we're going to use this right here, so we know that our y is our distance. So what do we know about the distance for truck 1? Well, it doesn't tell us the distance for truck 1, but we know that it's the same distance as truck 2, because if you're catching up to somebody, that means you've gone the same distance. What do we know about the slope or the rate? Well, it tells us right here that this guy is either pushing his truck or he's pulling it with a horse. We know they're going 8 miles an hour. And then what do we know about the time? It doesn't tell us anything about the time for truck 1. It tells us what time they leave, but it doesn't tell us how long he's gone. And that's the time that we're looking for. So we'll just leave x as x. What about for truck 2? What do we know about it? Well, we know obviously that the distances are the same. We know, so we can just set y equals ya. What do we know about the rate or the slope? Well, we know that this guy's got like an F-150 or a Silverado or something, because he's going 40 miles an hour. And what do we know about the time? Well, it's asking us to find the time, right? So we don't know anything about the time exactly. However, we do know that truck 2 leaves 10 hours later than truck 1. So if truck 1 leaves at x hours, then we know that truck 2 leaves at x hours, or the time that truck 1 travels, minus 10 hours, right? Now we have everything filled in that we need to, so we can go ahead and create our equation. So the equation for truck 1, y equals, the rate is m and x. And these are nice and solid for us, so they're ready to go in the graphing calculator. Here we have y equals, and then 40, and then our time is x minus 10, right? And we don't have to distribute this because the calculator will do all that hard work for us. So now we're to the point where we can go ahead and graph. So I'm going to go to the graphing part of this calculator. And before I start typing things in, I'm going to adjust the window, right? So we know that the minimum distance that you can go in life is 0. And we know, the minimum time, right? Time is x. And we know the minimum distance that you can go is 0. You can't go negative time. You can't go negative distance. Well, what is the maximum time that these trucks are going to travel for? Well, this says something about 10 hours later. So I'm assuming that they've gone at least 10 hours. So the max time here, I'm just going to make 15, right? And sometimes you're going to have to mess around with this window. So it's okay if we put it at 15. We have to come back and adjust it. You'll see that. And then the scale, well, from 0 to 15, going up by 1 is just fine, right? That's a perfect scale for 0 to 15. Well, for distance, we know it's min. What about the max distance? Doesn't tell us the distance, but if they're going for more than 10 hours and this guy's going 40, this guy's going 8 miles for at least 10 hours, right? Because this guy leaves 10 hours later. So that's at least 8 times 10, that's 80 miles. So I don't know, we'll just go ahead and put in 200. And we can come back and adjust it. And then the scale here, we don't want to go up by 1 from 0 to 200. Let's go up by tens. So let's make this 10. And then this is irrelevant. Now we can go ahead and type in our equations, and the first equation's right here for us. Y equals, and it doesn't matter what order you type them in, as long as you type them in correctly, 8x. Now I gotta move this window to type in the second one. Oops. No, we don't want that. What's the second one? Oh my. There we go. Adjust the window. Oh. Okay, you can kind of see it down here. It's y equals 40 parentheses x minus 10, and it's important that you close the parentheses. Now we can go ahead and graph, and you can see clearly that our window was just fine, right? We know that the solution is right here. So what is the x value that we can use in the table to get us close to finding the double y? Well, this is 10, this is 12. So it looks like it's just a tad more than 12. And the better you make your window, the easier it is to make this estimation, the faster you can get to it in the table. So we'll go ahead and put in 12, hit apply. Now we're looking for, do we need to go to previous, do we need to go to next? Well, let's look here. So 96 to 80, those are getting close. 104, so the difference here is 16. The difference here is 16. The difference here is more than 16, so it looks like we need to go to less values. The difference between these y's right here is 48 and 80. Let's go back. So this is a difference of 16. This is a difference of 16. So I'm thinking that it's somewhere in between 12 and 13. So this actually might be a decimal. So how do we handle a decimal? Well, let's just put in 12.5 and see what happens. So 12.5 and hit apply. So now we have our units in our x in 0.5s, and you can see right away when we put in 12.5, bang, there's our answer right there. 12.5, y is 100, y is 100. We know that that's the coordinate point they're intersecting on. So let me go ahead and write that right now. What was it? 12.5 for x and 100 for y. So let's go ahead and put that back into the context of the problem. X represents the time. Well, whose time do we want? If truck 2 travels 40 miles an hour, then how long will it take? So we're looking for truck 2's time. Here's the equation for truck 2. Here's time. Time is 12.5. So x is now 12.5 minus 10 equals, I'm not going to take any chances. Going back to the calculator. 12.5 minus 10, 2.5. So 2.5 hours. It takes him 2.5 hours to catch up to the guy who's pushing his car. So again, use the table to help you find the double y. If you have to make it a decimal to get closer to it, then you might have to make it a decimal. It's kind of trial and error when you get to that part. Good luck on the homework.